Hi guys, today we are going to be solving literal equations. So now the question is, what is a literal equation? A literal equation is an equation, but it's a special equation that consists primarily of letters. Okay, so when it comes to solving literal equations, we have to be told which variable to solve for. Let's go ahead and knock out problem A. Okay, so 8 equals 2x, and it's like, why is this problem in this unit? Whenever possible, I like to touch base on problems that I think you're comfortable with. So the directions read, I don't know if I read it, solve for the specified variable. So we have a grand total of, I think if I know how to count, 8 problems. Let's go ahead and knock out the first one. So we have 8 equals 2x. This equation only has one variable, so it's not vital for me to write solve for x. But I wanted to keep the wording consistent. Okay, so it's like, okay, how are we gonna handle it? It's like, we got this. To isolate the variable, to get rid of the times 2, let's go ahead, divide both sides by 2. So when we do that, will give us x equals 4. Variable is isolated, so we're good. Okay, but let's go ahead and look at another spicier problem. Problem B. So we have v equals L times W times H, and we're asked to solve for H. So if my memory serves me correct, I think this is the formula that's used to find the volume of a box, but it's not vital for us to know that to solve it, but let's just go ahead and do this. So this equation has more than one variable, so it is vital for us to be told which variable to solve for, and in this case we are asked to solve for H. So if you're not with the H, you gotta go. So the question is, how are we gonna isolate that H? How are we gonna get rid of the L and the W? To solve a literal equation, you need to identify the variable that you're solving for, and then just treat all the other letters like if there were numbers. Like, what are we gonna do to get rid of the times L? Oh, to get rid of the times L, let's go ahead, divide both sides by L. What are we gonna do to get rid of the times W? To get rid of the times W, let's go ahead, divide both sides by W. I didn't want to divide by one at a time, so let me start over without erasing anything. To get rid of the times L, we divide both sides by L. To get rid of the times W, we divide both sides by W. Now, to get rid of L and W in one swoop, to get rid of the times LW, we'll divide both sides by LW. So sorry for saying it like that. Okay, so again, to solve a literal equation, 1, identify the variable that you're solving for, and then 2, treat the other letters like if there were numbers, and just undo the operation. To get rid of a times, divide. To get rid of a plus, you subtract. Something that I want to point out is this. If the letters are presented in uppercase form or capital letters, you need to write them in uppercase form the whole entire time. If the letters are given in lowercase form, then you need to keep them in lowercase form. Why? Uppercase H and lowercase h, we know that they're the same letter, but in mathematics they represent 2 distinct variables, so watch out. Okay, so coming to our problem, quotient of L and L will give us 1, or they cancel, and the W's canceled out, and that will leave us H equals, on the left side we have a fraction, we can't reduce it, so let's do this. So that will give us H equals V over LW. We were asked to solve for H. H is isolated, so we're good. Okay, so again, we're doing a total of 8 problems. We got 2 down. Let's go ahead and knock out our third problem. So again, pause and rewind as many times as needed. So we have F equals, where am I? 7/5 times GH. So again, as you rewrite some of these letters, F and G, keep them uppercase at all times. H, keep it lowercase at all times, because you will definitely get dinged if you switch them out. And if there's no partial credit, then you get a 0. Okay, so we have this equation that has more than one variable, so it is vital for them to tell us what variable to solve for. In this case, we're gonna solve for G. All right, so if you're not with the G, you gotta go. So let me go ahead, highlight the G. Do you have to? No, but it makes me feel good. First things first, I want to wipe out the fractions too. So to undo the division by 5, let's go ahead, multiply both sides by 5. We're gonna multiply the left side and we're gonna multiply the right side. So when we do product of 5 and F, will give us 5F. Again, keep all uppercase upper and all lowercase lower. Quotient of 5 in itself is 1, or we say they cancel, and that leaves us with 7GH. So again, I need to remind myself, what variable am I solving for? So we're solving for G. So in this case, we want to get rid of the times 7 and we want to get rid of the times H. So all together, to get rid of the times 7H, let's go ahead, divide both sides by 7H. So on the left side, we have another fraction. Surprise. Let's ask ourselves, can we reduce it? Answer is no. So let's just go ahead, write down our result. So that will give us 5F is over. I keep saying equals for the fraction bar, sorry. So that gives us 5F over 7H equals 7's cancel, H's cancel, and that leaves us with the desired variable isolated. The desired variable is isolated, so we're good. Okay, so that was number 3. Let's go ahead, do number 4. So again, pause and rewind as many times as needed. Cool. Problem D. Where am I? Okay. Problem D, we have V equals a third times pi times r squared times h, and we are asked to solve for h. So we have a formula that's used to calculate the volume. I think it's a cone. I may have embarrassed myself. Don't quote me on that. Okay. Yeah, I don't know. Volume for something. Either way, I don't care. Okay. So we are asked to solve for h. So let me go ahead, identify the h. Okay. Do whatever you want. Okay. As long as you do it to both sides, you're good. For me, the fraction scares me, so let's do this. To get rid of the division by 3, you guessed it, let's go ahead, multiply both sides by 3. Okay, multiply both sides by 3. On the left side, product of 3 and V is 3V. Again, keep it uppercase. On the right side, quotient of 3 and itself will give us 1, or they cancel out, and that will leave us with pi r squared h. Too many letters, too much drama, so let me remind myself. So okay, we're trying to solve for h, so I need to get rid of this times pi times r squared. So to get rid of the times pi r squared, you guessed it, let's go ahead, divide both sides by pi r squared. Okay, so on the left side, what is that going to give us? So on the left side, we're going to have a fraction. Can we reduce it? No, so just write it as is. Again, make sure uppercase letters stay upper, lowercase stay lower. I sound like a broken record, but I can't stress that enough. Okay, I'm hoping that I drew that to your head. Okay, so that will give us 3V over pi r squared is equal to, pi's are out, r squares are out, and that leaves us with the desired variable isolated. Sorry for that. Cool. Alright, so that was problem number 4. Let's go ahead and knock out problem number 5. Okay. So problem 5, or E, we have 1/3 x minus 1/4 y equals what? Too many variables, so we have to be told which variable to solve for, and in this case we're asked to solve for y. Now, aside from the fractions, I don't really like it. Well, if we didn't have fractions, I would like it. Okay, but this problem I kind of like, because it reminds me of the section where we graph. Okay, so it's a little, I'm coming back home. First things first, we're gonna work our magic to wipe out the fractions. Do you have to? Absolutely not. But do I recommend? Yeah, love yourself. Get rid of them. So the denominators are 3 and 4, and I believe the least common denominator is 12. So let's go ahead and wipe out the fractions by multiplying both sides by the least common denominator of 12. So let me squeeze it in, because I don't have time to write this over. And again, you and mental math get along great. If you're like, Miss Torres, I'm on it. 12 times the third x, boom, gives us 4x. Then give me that simplified product. But for me, it's really hard to do that mentally. So you know me, I'm going to show my work. So we have 12 times the first term minus 12 times the second term. So again, you can write down the simplified product of I think 3y, or just show yourself your work. Love yourself. On the right side, product of 1 and 12. I don't want to sound like an overachiever, but I could do that in my head. So on the left side, let's simplify those products and take it away. 3 goes into 12 4 times, and that will leave us with 4x minus 4 goes into 12 3 times, and that will leave us with 3y equals 12. Fantastic. So again, we have the x and y variables, which I feel like I'm right at home, but either way I have to remind myself what variable are we asked to solve for, and in this case we're asked to solve for y. So if you're not with the y term, you gotta go to undo the 4x that's being added to our y. Let's go ahead and subtract it from both sides. And that will leave us with negative 3y equals, where am I? Negative 4x plus 12. The question that I get is this: does it matter which of these two terms I write first? It does not. You want to put the 12? Go for it. The only reason why I'm putting the x first is because from the graphing unit, I'm used to putting the x first, but you can put the 12 for all I care. Moving forward, to finish it off, to get rid of the times negative 3, to wrap up, isolate the y, let's go ahead, divide both sides by negative 3. Now, lots of students like to use the long fraction bar, and I'm all for it. The reason why I don't do that is because sometimes students just cancel out the constants and they don't look at the variable terms. So if I divide each term individually, then I avoid that mistake. Okay, so on the left side, quotient of negative 3 in itself gives us 1, or we say it cancels, and that will leave us with 4 and 3 have nothing in common other than 1, so you can leave this as 4x over 3. I'm not gonna be able to sleep tonight, so I'm gonna write it a little bit differently. Okay, so that you can leave it as 4x over 3. Quotient of 12 and negative 3 is negative 4. So we were asked to solve for y. Y is isolated, so we're good. Now, I'm not going to sleep well tonight, so I'm going to write this a little bit different. Instead of writing it as 4x over 3, I want to write it as fraction times x. I want to write it as 4/3 times x. Why? Because again, I'm thinking of the graphing unit. So that will give us y equals fraction times x. How does the book write it? It doesn't matter how the book writes it. Okay, as long as you've isolated the y, you're good. Okay, so it's up to you. Okay, I think that was our 5th problem. We got 2 more. So let me get my sheet of paper. Okay, problem P. Problem P. Sorry, I should go back to kindergarten. Okay, or wherever they teach the alphabet. Problem F. So now you're going to see why I said P. Okay, so we have P equals 2L plus 2W. So that's a pretty nice formula from back in the day. So that's the formula for a perimeter of a rectangle. But we don't have to identify the what geometric formula that is. Just read it, write it, identify the variable that you're solving for, and you're good. Okay, so we have P equals 2L plus 2W. Yes, it's a formula. In this case, we have more than one variable, so we have to be told what variable to solve for. We are asked to solve for the W, so if you're not with the W, you gotta go. Okay, so let me go ahead and highlight the W term. To undo the 2L, let's go ahead and subtract it from both sides. And the question is, why do we do so many problems? I'm hoping that if I give you a nice set of problems, then you can attack any problem that you see for homework, quiz, or test. So I guess you're welcome. Okay, so on the left side, P and 2L are not like terms. We cannot combine them, so we'll just write them side by side. It doesn't matter if you put the P or the L first. It's a personal choice. For me, I like to start on a positive note, so I'm going to put the P first. So I'm going to put P minus 2L is equal to 2W. And gentle reminder, what are we solving for? So we're asked to solve for W. To get rid of the times 2, let's go ahead, divide both sides by 2. And you know my speech, I love myself, so I'm going to divide each term by 2 instead of using the long fraction bar. On the right side, the 2's cancel out, and that will leave us just with w. On the left side, we have p over 2 minus quotient of 2 in itself is 1, or we say that cancels, minus L. The W is isolated. Remember to keep uppercase upper, lowercase lower. Cool. So you really can't see this because I smeared it. Sorry. Okay. So normally I would just leave it like this and move on for almost grand finale, but I want to tell you what your book does. So let me just put book. We're not going to do it from the beginning, but we're going to take it from this step. Okay, so we have p minus 2l equals 2w, and again we're asked to solve for w. So same speech, to get rid of the times 2, we're going to go ahead divide both sides by 2. And this is where me and your book fight. Well, not necessarily fight, it's just slightly different. Okay, so you know my speech. I don't really like the long fraction bar, but I want to tell you why your book decides to use a long fraction bar. So your book says this, we're supposed to divide both sides by 2, but we notice that 2 doesn't go into p and 2l a clean number of times. And your book hates fractions. So to avoid having a fraction, we'll just use the long fraction bar. Okay, so it's fine. You can do that. Okay, you can do that. You divided both sides by 2, whether you use the long fraction bar or just divide each term by 2. So on the left side, we have a fraction, and I'm going to ask myself, is it reduced? Okay, I can't do too many things at once, so let me write it and then ask the question. On the right side, 2's cancel out, and the desired variable is isolated. So we have w equals a fraction. So fractions are fine. Just ask yourself, is it reduced? Well, in this case, p, 2l, and 2, all three terms don't have any factors in common other than 1. So the fraction is reduced. Now question, which answer do I want to see? You know what? They're both correct. So I want to see whatever makes you happy. So what I want to point out is this. Let's just pretend you did it like this. And then you look at the back of the book and it doesn't look quite like your answer. For this section, I don't want you to freak out. You know, try to see what they did. Like, oh, are they equivalent? Oh, p divided by 2? I got p divided by 2. Minus, I got a minus. 2l divided by 2? Oh, that gives us l. I got a l. So although the expressions are, although our equations don't look the same, the expressions are equivalent. So you can give me whatever works for you. When it comes to fractions, just make sure they're reduced. Okay, I think I said too many words. Let's go ahead and knock out these 2 problems so we can leave for the day. Alright, where am I? Problem G. Problem G, we have a equals p, open parenthesis, 1 plus rt, close parenthesis. Too many variables, so again we have to be told which variable to solve for. So again, gentle reminder, all uppercase letters keep them upper and lower keep them lower. Okay, so we are asked to solve for r. Okay, so let me go ahead highlight that term. We cannot read each other's mind, so but this is how I'm gonna approach it. That r term is inside our grouping symbol. So for me, I'm naturally inclined to get that r term out of the grouping symbol. So let's go ahead to distribute that p. So when we do p times 1, I feel like a genius. It's just p. P times rt is just p times rt, or prt. Alright, bam, that r guy out of the grouping symbol. So again, let me highlight it. Okay, well, I'll highlight the whole term. Okay, if you're not with the r, you gotta go. Okay, so to undo the addition by p, let's go ahead subtract it from both sides. And then a and p are not like terms. They look like d's, sorry. Okay, a and p are not like terms, so just write them side by side. A minus p or negative p plus a, personal choice, equals p r t. Cool. So we have the r term isolated, but now we want to isolate that r itself. So I'm like, oh man, what am I gonna do to get rid of the times p? We got it. Divide both sides by p. What are we gonna do to get rid of the times t? Same speech. Divide both sides by t. All together, what are we gonna do to get rid of the times pt? Yes, say it with me. divide both sides by PT. So let's do this. Divide both sides by PT. And I'm at a crossroads, how should I show my division? Should we divide each term by PT, or should we use one long fraction bar? That's gonna be a personal choice. For me, PT does not go into A and P a clean number of times, so I'm just gonna use the long fraction bar. And if you're like, nope, I'm gonna just divide each one, go for it. Okay, our answers will look a little bit different, but it's cool, they're gonna be equivalent. So on the left side we have A minus P over PT equals P's are out, T's are out, and that gives us R. Desired variable is isolated. All the uppercase are upper, lowercase are lower. We got a fraction, we cannot reduce it, so we're good. Cool. All right guys, I said we're gonna do 8 problems. Oh, one more. Okay, last one and we're out for the day. Okay, problem H, we have A equals 1/2 open parenthesis B1 plus B2. So I guess we like B so much that we put 2 of them, and so we have to put subscripts. Okay, close parenthesis times H. So we have too many variables, A, 2, 3, 4 variables, so we have to be told which variable to solve for, and in this case we're gonna solve for B2. So let me go ahead, circle that B2 term. Once again, the desired variable is inside a grouping symbol, so you know me, I want to get it out. Normally I would say let's distribute the 1/2, but I don't want to distribute a fraction, so let's just get rid of the denominator. To get rid of the division by 2, let's go ahead and multiply both sides by 2. So times 2, squeeze it in, times 2. On the left side, product of 2 and A is 2A. On the right side, quotient of 2 in itself gives us 1, or we say it cancels, and that leaves us with B1 plus B2, and that sum is being multiplied by H. So again, I gotta remind myself, what am I solving for? I'm solving for B2. Okay, so B2 is still inside a grouping symbol. Let's get rid of it. Let's get it out of the grouping symbol. Let's distribute the H. Okay, on the left side we have 2A. On the right side, H times B1 is just H times B1. H times B1 plus H times B2, you got it, H times B2. So again, gentle reminder, what am I trying to solve for? We're trying to solve for B2. So if you're not with that B2, you gotta go to undo the addition by HB1, then subtract it from both sides. I gotta get better pens, sorry. They look nice, but they smear very easily. Okay, so on the left side, the terms are not like terms, so write them in any order if you're liking. Just make sure that 2A is still positive and HB1 is still negative. Equals HB2. Okay, we're almost out of here. Okay, so we want to solve for B2. To get rid of the times H, you guessed it, we're going to divide both sides by H. So the question is, should we use a long fraction bar, or should we divide each one by H? That is a personal choice. Whatever technique you select, just make sure that your fraction is reduced. This is how I do it. Does H go into the first term? No. Okay, that's it. Since H doesn't go into both of these terms, and I don't want to deal with little fractions, so I'll just use the long fraction bar. Okay, so on the left side we have 2A minus HB1 over H equals B2. Desired variable is isolated. B2 equals a fraction. Just ask yourself, is this bad boy reduced? It is, because 2A, HB1, and H, all 3 terms don't have any factors in common other than 1. Okay, so at the beginning of this video I said we were gonna do 8 problems. That's number 8. Yay! Okay, so end of section. Thanks.